Hi, this is CAD/CAM Lessons channel. In this video, I will show you the basics of Fusion 360 regarding 3D modeling and preparing machining programs for CNC milling machines. Fusion is a CAD/CAM system in which we can create our own 3D models and prepare toolpaths for CNC machines. If you haven't subscribed to this channel yet, please subscribe, and if you want to support this channel, you will find information in the description of this video on how to do that. For smooth navigation, I use 3D Connection Space Mouse Wireless Pro. With discount code DamianCADCAM, you can buy this and other 3D connection devices with a 10% discount. Details in the description of the video. Now we will move on to Fusion and start by creating a 3D model, based on which we will prepare toolpaths. We will begin by creating a sketch. Select the Create Sketch command, and here select the plane on which we will create the sketch. Select the XY plane as the sketch plane, and here we will create a rectangle whose center will lie at the origin of the coordinate system. To do this, from the Create menu, select Rectangle and then select Center Rectangle. Next, as the center of the rectangle, select this point, which means that once the cursor is grabbed by this point, click the left mouse button. Next, we define the dimensions of this rectangle. Here enter 70 millimeters. Press Tab, and here enter 100 and press Enter to confirm. Close the sketch, and based on this sketch we will create a solid by extruding the sketch. We select the area we want to extrude and choose the Extrude command. This command can also be activated by pressing the E key on the keyboard, but now let's select it from this icon. Here we add the extrusion. As you can see, we can add an extrusion by dragging this arrow, or we can specify a specific value for the extrusion and enter 25 millimeters here. We can also enter the extrusion value in this place and click OK. Next, we will add fillets to the corners of this solid. To do this, while holding down the Shift key, select the 4 edge corners of this solid. Once we have selected the 4 edges, we choose the Fillet command and add a radius of 10 millimeters here. We can do this by dragging the arrow or simply entering a specific value here. Type 10 and press Enter to confirm. Now we will create another sketch, and when it comes to creating sketches, we can create sketches on the planes of coordinate systems and on the faces of the solid. Now we will create a sketch on this face. Select this face and choose Create Sketch. Here we will create this sketch in such a way that we will create geometry by offsetting the outer edge of the solid. To do this, we select the Offset command, select the edge of the solid, and here we specify the offset value. We will offset inward by -10 millimeters. We enter that value and press Enter to confirm. We close the sketch, and now we will remove material based on this area. We select this area, and we will also use the extrude operation to remove material. So I press the E key on the keyboard. Now if I drag the arrow upwards, another part of the solid will be created. But if I drag this arrow downwards, I can remove material from this area. Here, drag the arrow to -15 millimeters or enter that value in this place. If it looks different on your screen, pay attention to what type of operation you have. Here we want to remove material from the solid, so it is important to have the cut option selected as the type of operation, and we click OK. In this way, we created something like this. Now we will add chamfers to the corners of this part of the solid. With the Shift key, select the 4 corners of this part of the solid. OK, select the chamfer operation. The chamfer operation is in the Modify menu, and it is chamfer operation. Select this operation, and here, similarly to the fillet, we specify the chamfer value. We can do this by dragging the arrow, or we can enter a specific value here. Enter 10 millimeters as the chamfer dimension and press Enter. Next, we will create another sketch and add another operation for creating 3D solids. We will create a sketch on this face, select this face, and choose Create Sketch. Here we will create the geometry of a slot. Select the slot command and choose Center to Center Slot. Create the slot by pointing to 2 points of the slot. For now, we won't worry about dimensions. We need to specify the third point. Now press Escape to cancel this command. And this slot is created in such a way that its position is not defined and its dimensions are also not defined. We can freely change the dimensions and the position of this slot. Now, I would like this slot to be placed in such a way that it will lie at the center of this part of the solid. To do this, we will use constraints. First, add dimensions to this slot. Select this line and activate the dimensioning command, which is the sketch dimension command. Select this command or press the D key on the keyboard and here enter 40 mm as this dimension. OK. Next, select this arc and here enter 15 mm as the radius. Now press the Escape key to cancel the dimensioning command and we will define the position of this slot. In this case, to place this slot at the center of this solid, we can do this by using a constraint that will connect this point with the midpoint of this line. To do this, select the midpoint constraint. The line was already selected, so now select this point and this slot is already positioned at the center of this line. Press the Escape key to cancel this. And here we still do not have the position of this slot defined. As you can see, I can rotate this slot and I can easily damage this geometry, but this can also be easily fixed. Deselect all geometries, click with the left mouse button somewhere outside the drawing so that no geometry is selected, and select the horizontal vertical constraint. Select this point, and now this constraint will ensure that these 2 points lie in a straight line. Although actually in this case we could also do it in such a way. I press Ctrl-Z to go back to that moment when we could just state that this line should be a horizontal line. And here that constraint also ensured that the position of this slot was determined. Close the sketch, and now based on this sketch we will remove material from this solid. I select the area based on which I want to remove material, press the E key to activate the extrude command and drag this arrow down to -10 mm, or enter the value -10 here and click OK to confirm. Now we will create holes in the corners of this solid, and actually we could have created these holes at the very beginning. We could have created these holes in the first sketch, and at this stage of creating the 3D solid, we can also do it. We can go to edit the first sketch. Here we have the history of operations. And now by double-clicking the left mouse button on this sketch or right-clicking, we can select Edit Sketch and we can go into Edit the Sketch and we can make some changes here. However, in this case, it will be easier to add these holes at this stage, as we will use the center of these fillets. Select this face and choose Create Sketch, and we will create circles that will lie at the midpoint of this arc. Select the circle drawing tool, and here, as you can see, using the snap, we can easily place the center of the circle at this point, and here enter 5 mm as the diameter of the circle, and press Enter. In a similar way, we can create circles in the other corners of the solid. Select the circle drawing tool and draw a circle, and for now, draw circles of any diameters so that the centers of those circles lie precisely at the midpoints of the arc. Press Escape to cancel this command. Now, I would like all circles to have the same diameter. We can dimension each circle individually, but we can also select all circles with the Shift key. Select the equality constraint, which will ensure that all circles have the same diameter. Press Escape, and now this has the advantage that when I change this dimension, and to change this dimension, double-click the left mouse button, and for example, I enter here 8 mm, press Enter, the diameter of all circles has been changed. Close the sketch, and based on these circles, we will create holes in this solid. With the Shift key, select the areas of those holes. Press the E key to activate the extrude command and drag this arrow down to a value greater than the thickness of this part of the solid and click OK to confirm. In this way, we created something like this, and based on this simple 3D model, I will show you the basic milling operations available in Autodesk Fusion. Okay, we have created the model, and now we will move on to the manufacturer module to prepare the toolpaths and CNC milling program based on this model. Here, we select the manufacture module and we can start preparing machining programs for CNC mills. The first step to take is the initial setup. To do this, we click this button, create a new setup, and here we specify the position of the coordinate system. This is a fairly important step, as later on the machine we should place the origin of the coordinate system in the same location on the workpiece. If here, during the preparation of the machining program, the origin is in the center of the workpiece, and on the top surface we should place the origin in the same place on the machine, we will leave the origin here. As you can see, we have 27 specific points where we can place the origin. However, the center point is a relatively safe point, and if you already have greater experience in preparing machining programs, you can choose a different point. We will place the origin here, and now we will move on to specifying the dimensions of the stock. When it comes to the stock, we currently have the relative size box option selected. In this case, we specify the dimensions of the stock relative to the model we will be machining. Here, we define the allowances on the sides and the allowance on the top and bottom of the part. Regarding the side offset, if I change the value here to 10 mm, the workpiece will be enlarged by 10 mm on each side. Let's return here to a value of 1 mm. It will work similarly for the top allowance. Okay, let's also return to 1 mm here, and for the bottom allowance, let's set it to 5 mm. In fact, we can finish the initial setup here. We have the post-process tab, but at this stage we don't do anything here. We click OK, and we have set the setup. This is the coordinate system relative to which the toolpaths will be calculated and the machining program will be generated. Therefore, on the CNC machine, the coordinate system should be placed in the same location, as the program we prepare in Fusion will be executed based on this coordinate system. The first machining operation we will apply here will be the facing operation, which allows for the quick and efficient removal of material on the top of the part. Typically, for such an operation, we use a milling head that has a relatively large diameter and allows for fairly rapid material removal from flat surfaces. When it comes to the operations we will be using in this tutorial, they will be operations from the 2D operations group. Regarding the facing operation, it is the face operation. And here we also have the icon for this operation. Let's select this operation. And first, we need to choose the tool we will use for machining. To do this, we click the Select button, and here we will use the tool library available in Fusion. Let's select Milling Tools here. If this library is inactive for you, please click this button. I already have this library active. And here we choose the tool for facing. We can check the face mill filter, and here it will display the tool we will use. We select this tool, check it, and click the Select button, or simply double-click the left mouse button. OK, the tool is selected. This tool is defined in the Fusion library, and such machining parameters are assigned to this tool. If you would like to change these parameters only for this operation, you can do it here, and if you would like to use different parameters for this tool, you can create a new tool based on this tool with different parameters. However, for now, we will leave these parameters as they are. We won't change anything here. We will use the tools and parameters assigned in Fusion. Now we move on to the next tab. We can skip this tab and go to the Geometry tab, where geometries are simply selected by default. When it comes to facing, we can also skip this tab and go directly to the Heights tab. At this moment, the most important levels will be the top machining level and the bottom machining level. As for the other levels, feed height, retract height, and clearance height, if they are above the top height level, everything should generally be fine. Here let's focus on the top height level. The top height level is defined in such a way that it is the level that is 0 mm above the top level of the stock. So in this case, the top machining level is the top level of the stock, and the bottom machining level is the top level of the model. This machining will be performed from the top level of the workpiece to the top level of the model. That is, we will simply remove the material that is between the top level of the stock and the top face of the model. We have 1 mm of allowance here, and in this operation, we will remove this allowance. That's why I mentioned earlier that we don't have to worry about those levels, because they are above the top machining level, so if the tool moves in rapid move, in the case of machining such a single part, we don't have a risk of collision. So we can leave such values at these levels and move on to the next tab, the Passes tab. Regarding this tab, in this case I suggest doing something like this. We leave the default parameters and click OK to recalculate the toolpaths and see how it will look. In this case, the machining will be performed in this way. We can run a simulation to visualize this machining. To do that, we right-click on the operation for which we want to run the simulation and select Simulate. Here we have several simulation modes, but we will start the step-by-step simulation. By clicking this button, step by step, we can observe how this simulation will proceed. Okay, we have the tool entry into the material and the first machining pass. Next, we have the tool moving to the second machining pass. And we have completed the second pass. We have a move to the third pass, and we have completed the third pass. In these three passes, we have removed material. This machining is correct, but we can also modify this machining. And based on this simple machining, I can show you several essential parameters that will also appear in other machining strategies. And based on this simple machining, everything will be clearly visible regarding how these parameters work. We have a face milling operation created here with default parameters, and now we will check the selected parameters of this operation. Now we will proceed to edit this operation. To edit this operation, we right-click and select Edit, or we double-click the left mouse button on this operation. So, let's go straight to the Passes tab. The first parameter I want to draw attention to is the Pass Extension parameter, which is the extension of the passes. Here, if I change this value to, for example, 55 mm and click OK, these passes have been significantly extended. This doesn't really make much sense in this case, as the tool will be working in the air, so we're just wasting time. But sometimes this parameter can be useful. I will go back to editing this operation and change the value of this parameter to 25 mm. The next parameter, which is quite important, although in this case the default value of this parameter is correct, is the step-over parameter. It also appears in other strategies, and it refers to the distance between the passes. Here we have 35 mm, and if I change this value to 5 mm and click OK, the toolpath will look like this. As you can see, we have a lot more passes. The passes are denser, and by using such machining, the machining will be smoother because the tool will remove less material in one pass. Of course, the machining will take longer, but if you have, for example, a weaker machine, by adjusting the step-over parameter, you can determine the width of one pass. I will go back to editing this operation and return the step-over parameter to 35 mm. Next, an important parameter is the direction parameter. At this moment, the machining is set in two directions. We can set the machining to be climb milling or conventional milling, then the machining will be done in one direction. That is, a pass will simply be made, the tool will retract, move to the start of the next pass, and so on. It will work in one direction. We will not have both climb milling and conventional milling. Only one milling method will be used throughout the machining, which can be very useful in some cases. Because in the case of some tools and some materials, when we mill in a climb milling manner, the surface quality after machining is better than in the case of conventional milling. I will go to edit this operation, and here we will return to the both ways parameter so that we can mill in two directions. Another important thing is the situation where we would like to perform this machining in several passes along the z-axis. At this moment, this machining is being done in such a way that we have one pass along the z-axis, and in this case we only have a millimeter of allowance, so we shouldn't have any problem performing this machining. But if there were more allowance, or if you wanted to leave a small allowance for machining in the next pass so that the last pass would be a finishing pass, we can do this in the Passes tab. By checking this multiple depths parameter, we can specify the maximum value of one step, but we can also check the finishing step parameter and specify the value of the finishing pass. For example, by entering 0.2 here, we can also change the feed rate for this finishing pass. That is, within this one operation we can prepare rough machining, and we can leave a small allowance for the finishing pass. This finishing pass can be performed with a different feed rate value. I click OK, and now it looks like this. We have the first rough pass here, then there is 0.2 mm allowance left for the finishing pass, and later this pass will be completed. As for this tab, the multiple depths tab, this tab also appears in other strategies, and it is worth paying attention to this tab if we want to change the number of passes along the z-axis. And okay, we will leave this face machining as it is and move on to the next machining strategy. We will prepare contour machining. The next basic machining strategy we will discuss is contour machining. Contour machining involves removing material along a specified boundary. In terms of contour machining, it falls into the category of 2D machining. It is a 2D contour machining operation that we can activate by selecting this option or by clicking this icon. We choose this operation and will start by selecting the tool we will use for this machining. We click this button, and from the Fusion tool library we will select an end mill. Here in the filters we can choose flat end mill and select a 12 mm diameter end mill. Okay, next let's go to the Geometry tab and select the contour we will machine. We will machine this contour. Let's point to the bottom contour, because here we can select both this contour and this contour, but by selecting the bottom contour as the contour to machine, the milling depth will also be read. We also have an arrow here that simply defines the machining direction. Okay, now I need to click on this arrow in some way so that it jumps to this side. But if we cannot do that, we can also do it here. Just pay attention here that I've selected the face as well, which is why I have this face selected. And I click this button to remove the geometry to be machined. We have a machining chain here, and I right-click, select Flip Directions, so the arrow goes back to this position. Now let's go to the Heights tab. And here we have the levels set up this way. Regarding the clearance, retract and feed height levels, we can leave the default values. We focus on the top height and bottom height levels. The top height level is set to the upper level of the stock, and the bottom height level is set to the level of the selected contour. That's why we selected the bottom contour for machining, to read the milling depth directly. As for the upper machining level, we can change the upper machining level since the stock top level has already been removed. We no longer have stock on the top of this part. This stock has been machined, and the upper level for machining is simply the top of the model. We can select this from the options. Let's choose the model top here. and now the upper machining level will be the top of the model. Let's go to the Passes tab, and as you can see we have a few parameters to set here, but let's click OK first to see how this machining will look with the default parameters. And this machining looks like this. We have one pass along the contour at full depth. I will run a simulation of this operation. And it looks like this, and it doesn't look the best. For this type of machining, we can approach it in a few different ways. Now, we will discuss the basic parameters of this operation. I'm going to edit this operation, and so we move to the Passes tab. As for contour machining, we can do it in such a way that we can apply a large milling depth and a small milling width, or we can apply a large milling width and a small milling depth. This we choose depending on preference, depending on the tool used, depending on the material being machined. And now, to prepare the machining in such a way that we will have a small milling width and a large milling depth, we need to specify the parameter that corresponds to this milling width. This is the step-over parameter, which also appeared in the case of face machining. To be able to determine this parameter, we need to check this option for roughing passes. Now the step-over parameter has appeared here, and we also have the maximum step-over parameter. For now, let's leave it as it is and click OK. Let's see what has changed. We simply have one additional pass, and this additional pass is added because as the number of passes resulting from this roughing operation, we have the value 1 entered here. We can enter, for example, 10 here. I click OK. And then this machining will be generated in this way, but here we have the maximum value of the step-over parameter set to quite a high value. Therefore, I go back to editing this operation, go to the Passes tab, and here as the maximum step-over I will enter, for example, 2 mm, and click OK. Now, this machining looks like this. Running a simulation of the machining, it looks like the tool in the first passes will be milling in the air. Here, as you can see, where we have the machining at these corners, the material is being removed, but here on these straight sections there is no milling. The tool is working in the air. For now, we will leave it this way. I'm closing the simulation, and this is one of the approaches we can take. The second approach is that we work with a fairly large width of the tool, but apply a small depth. I'm going to edit this operation. Here I will turn off the roughing passes parameter, and we have the multiple depths tab here. Here we can define the depth of the pass. Let's select maximum roughing step down, enter 2 mm, click OK, and now this machining looks like this. The depth of a single pass is a maximum of 2 mm. Such machining, where we work in several passes in the z-axis, can also be combined with the previous method of machining. To do this, I go to edit the operation, go to the Passes tab, and here I additionally check the roughing passes section. At this moment I might reduce the number of these passes, for example to 5. I click OK. We have something like this. We have both additional passes in the XY axis and additional passes in the Z-axis. However, as you saw in the case of the previous machining, in those initial passes, material was only removed at the corners, and here, in the case of machining over those straight sections, the tool was working in the air. In this case, we can split this machining into two strategies. In the first strategy, we can machine the corners, and in the second strategy, we can machine the contour. We will add another contour machining operation here. I choose contour machining. We will use the same tool and go to the Geometry tab. As the contour to be machined, I would like to select only those corner edges. As you can see, the entire contour has been selected. Again, this machining will be prepared in the same way as we did in the previous strategy. To select only a single edge of this contour, we right-click here, select Edit, and here as a mode we have Closed Chain and Open Chain. Select Open Chain, and here only that edge was specified. Here we can also apply an extension of this geometry. I will add an extension of 2 mm at the beginning and at the end, and click OK. Now we add another chain. Here again, the entire geometry is selected. I right-click, Edit, Open Chain, and here I will also extend it by 2 mm. OK, and we will do the same with this second chain. We edit it and also extend it by 2 mm. OK, and we add one last geometry. Select this chain, right-click, Edit, Open Chain, and also 2 mm extension. I click OK, and we have selected 4 corners. We can click OK to recalculate this machining with the default parameters, and that's how it looks. Now we can apply the parameters we discussed earlier. Let's go to the Passes tab, and let's check the Roughing Passes tab here. As the value of the step over parameter, we have 1.2 mm here. Here, set the maximum value of the step over parameter to 2 mm. And let's add, for example, 4 passes. I click OK to see how it will look. We can run a simulation of this operation, but see what will happen now. Here, this operation is prepared after the previous operation, so we need to change the order of operations. I exit the simulation, and now to change the order of operations, we simply drag this operation above this operation. Now the order of these operations has been simply changed. I right-click, select Simulation, and let's run a simulation of this operation. As you can see, we still need to add some additional passes, as the corners will not be fully machined. OK, I'm closing the simulation. I'm going to edit this operation. We go to the Passes tab, and here, as the number of passes I will enter, for example, 10. OK, and let's see how it will look. I'll go to the simulation and run the simulation. And OK, the first pass is a bit bigger, but here we have less material, and we can leave it this way. OK, I exit the simulation, and now we have this machining, and we can slightly modify this machining. I'm going to edit this machining. Here we no longer have materials in the corners, so we are left only with these straight sections, so we can change this machining a bit. Here, according to our preferences and capabilities, we need to determine how many passes in the Z-axis we will apply, and how many passes in the X and Y axis. As for additional passes in the XY axis, we can leave this number of passes as it is. And as for the maximum roughing step down parameter, let's enter a higher value here. For example, 7 mm, and click OK. Now this machining will be prepared this way. Of course, here I want to show you the principle of these parameters, so you know where to find parameters that allow you to determine the number of passes in the Z-axis and the number of passes in the XY axis, so we can make this machining a bit gentler so it doesn't overload the tool and the machine so much. We simply adjust this to our own capabilities. As for contour machining, it's worth paying attention to the parameters regarding the tool's entry and exit. To show you this, I will prepare another operation that will be prepared in such a way that we simply prepare a single pass along the contour. I click OK, and this is how this machining looks. When it comes to the tool's entry and exit movement, that is the movement we see here. We can adjust this by going to edit the operation and doing it in the linking tab. Here we have a section for leads and transitions. The lead and entry parameter corresponds to the entry movement, and the lead out exit parameter corresponds to the exit movement of the tool from the material. We have the option same as lead in checked, that is, the retraction movement of the tool has the same parameters as the tool's entry movement. At this moment, I want to show you that there is something like this, and at this point we can adjust it. For example, I will enter a larger value here. I will set 5 millimeters here, and for example set 10 millimeters here, and I click OK. You see that these movements have already been changed, and it looks much different than what was earlier. So at this point you can adjust the entry and exit movement of the tool to your needs. As for this operation, we will leave this operation because I will need it shortly, but if you wanted to remove any operation from the operations you added, you simply right-click on that operation and select the delete option here. I will leave this operation because in the previous operations I will add allowances for finishing machining. To add allowances, I will edit this operation. I right-click here, select Edit, and regarding allowances, they are also in the Passes section. We have the Stock to Leave section here, and we specify allowance on the sides and allowance on the Z-axis. As for allowance in the Z-axis, I do not want allowance, and as for allowance on the sides, I leave 0.5 millimeter of stock for finishing machining here. I click OK to confirm this, and we do the same in this operation. I right-click, select Edit, go to the Passes tab, and go to the Stock to Leave section. In the Z-axis set 0, and on the XY axis 0.5 millimeters, and I click OK. Now I will run a simulation of this operation. And as you can see, what is displayed in blue is the allowance that will be left after this operation, and this allowance will be machined in the next operation. I exit the simulation and we have contour machining in one pass, but here there is a small allowance left for machining, so the tool should be able to handle something like this. I choose to simulate this operation, and now in this operation we have a small amount of stock to remove, and this is how this machining looks. I close the simulation, and in this way we can prepare contour machining. The next operation that we will add to the processing of this part will be a pocket machining operation, which removes material inside a defined boundary. In this case, we will remove material from this part of the solid. As for the pocket machining operation, it is also an operation from the 2D machining group, and it is a 2D pocket operation. Let's select this operation. For the pocket machining, we will use the same tool that we used for contour machining, so we don't need to change this tool. This tool is automatically selected, and we go to the Geometry tab to select the geometry to be machined. Regarding the machining geometry, just like with contour machining, we select the bottom surface of the pocket so that the lower machining level can be automatically read. We move to the Heights tab to see what these levels look like. Here, just like with contour machining, regarding the top height level, we can change it to Model Top. However, for the bottom height level, this level corresponds to the selected geometry, so we will leave it as is. We move to the Passes tab. As you can see, we have several parameters here. What is worth noting at this point is that we have machining allowances automatically checked. If this section is checked, we will leave 0.5 millimeters of allowance on the side and 0.5 millimeters of allowance on the bottom of this pocket. For now, we leave the default parameters and click OK. This is what the toolpath looks like for the pocket machining operation. As you can see, the red line indicates the tool entry, and this tool entry is executed in a helix motion. Regarding the tool entry parameters and the parameters of this helix, we can do that in the Linking tab. Here we have a ramp section, and here we specify the parameters of this helix. You can enter various values here to see how this helix changes. But in this guide, I just want to point out that we can change it here. Now let's go back to the Passes tab. I would like to prepare this machining in several passes in the Z-axis. I want to prepare this machining so that there is no allowance left on the bottom. So here we will set the allowance to 0, and we will leave 0.5 millimeters of allowance on the side. Regarding several passes in the z-axis, we check this section and specify the value of the parameter corresponding to the step in the z-axis. Here we have the maximum roughing step down, which is the maximum value of the machining step in the z-axis. Let's leave the default values and click OK to see how this will look. As you can see, additional passes in the z-axis have been added. If we would like to add more passes in the XY axis so that the machining in these axes is also smoother, we need to change the value of the step over parameter. We edit this operation, go to the Passes tab, and here we have the value of the maximum step over parameter. We can decrease this value. I click OK, and here additional machining passes in the XY axis have been added. Let's run a simulation of this operation to see how it will look. As you can see, the tool plunges to the depth of one pass and performs the machining. It continues to repeat this machining until it reaches the maximum depth. There is 0.5 millimeters of allowance left for the finishing machining on the sides of the pocket, and we will now add another machining strategy. We can simply perform this finishing machining using contour machining. We add another 2D pocket strategy and select the geometry for machining by selecting the contour of the pocket. I click OK to see how this machining will look. Here I have chosen the wrong machining strategy, so I remove this operation and select the 2D contour. I made a mistake, I just selected the 2D pocket strategy. I select the geometry for machining again, click OK, and with the default parameters, this machining looks like this. There is one thing I do not like here. I do not like the tool entry point into the material. I would prefer if this entry were on this straight segment, from this side or from that side. Now, we will change that. We go to edit this operation, go to the linking tab, and here we have a position section. We have something called preferred lead in position. We click select and click roughly in this spot. We click OK. Now the tool entry and exit are in this place. If you have the need, you can also adjust the entry and exit movements of the tool, but at this moment we can leave it this way. This is how we can prepare pocket machining with an additional finishing pass, executed using contour machining strategy. The next operation we will perform here will be drilling holes. These are operations carried out using the drill strategy. As for the diameter of this hole, we can take a look at it. If you click on the face of the hole, we have information about the radius, which means the diameter is 8 millimeters. We select the drill strategy, and here we need to use a different tool. We click the select button and choose a tool from the hole making tools group. If this tool library is not active, click this button. And here, let's select a tool from the spot drill group to prepare for the drilling. We have spot drills with a point angle of 90 degrees, but let's switch to the milling tools library now. As for the spot drill tools, we also have spot drills with a point angle of 120 degrees, so let's choose that tool. Okay, now we go to the Geometry tab, and here we select the faces of the holes. Okay, and this face too. We have selected 4 holes. And one thing that's worth doing at the beginning, if you're starting to work in Fusion, is simply to calculate the toolpath with the default parameters. As for this toolpath, I don't like it because these holes will be drilled to the bottom level of the hole. Here we only want to spot drill. To do this, we go to edit this operation, and we need to change the machining levels. We go to the Levels tab, and as for the top height level, we have this level set to hole top, which is at the upper level of the hole, and that's okay. But as for the bottom height level, we have this level set to the lower level of the hole. So let's change this parameter to hole top. And now, when you click OK, nothing has been generated. We have an error here, and this is the correct reaction of Fusion, because the top level and the bottom level of drilling are at this level, so we have nowhere to perform this operation. But we have an offset parameter here, and we input the depth we want to drill. I will input -1 mm and click OK. And now this operation looks such that there will be a slight drilling. As for the tools passes, they will be performed above the model, so we can leave this operation as it is. Let's also run a simulation of this machining. Okay, here the tool performs the drilling. And that's how it looks. We close the simulation and add another operation. We select drilling, and now we select the tool. We choose a drill with a diameter of 8 mm. Let's select this tool from this tools group. We select drill here, and we have an additional filter. Here we can enter a diameter of 8 mm. We have an equal value so that it only displays tools that have a diameter of 8 mm because we need that drill. We select this tool, and now we go to the Geometry tab, select the faces of the holes, and as before, click OK with the default parameters. And here it looks better already, but it doesn't look quite right because we have drilling performed to the lower level of the hole. The tip of the drill reaches this level, which means that this drilling will not be through. There will simply be some unmachined material left here, and we can also make those changes. We edit this operation, go to the levels, and here, as the bottom level of machining, the bottom level of the hole is selected. We can apply an offset, but we can also check the drill tip through bottom parameter. We check this parameter, and it is already visible in the preview how it will look. Additionally, we could apply an offset of -1 mm to ensure that the tool's cylindrical part completely exits the material. Go to the Cycle tab, and here, as for drilling, we can perform the drilling using a cycle. The default selected cycle is drilling rapid out, which is simply standard drilling. The tool will start machining and will complete this hole entirely in one pass. In some cases we can leave this, but we could also choose the deep drilling full retract option here and specify the drilling value for one step. For now, I will return to drilling rapid out. Click OK and run a simulation of this drilling. And here the tool simply drills the hole completely, in one pass, plunges to the bottom depth of drilling and retracts. And as for deep drilling, I edit this operation and change the drilling cycle to deep drilling full retract. We have the depth for one step of drilling. I will leave it as it is. I click OK. Nothing has changed in the toolpath, but when we go to the simulation of this machining, the drilling looks like this. We have drilling to the depth of the first step, retraction, drilling to the depth of the second step, retraction, and so on, until the tool reaches the full depth of machining. Okay, this is how the drilling will look. I close the simulation, and as for drilling, this is how we can prepare this operation. The next operation we will add to the machining of this part will be the chamfering operation. We will add chamfers to the outer edge of this solid part and to the upper edge of the pocket, and later we will also add chamfers in the holes. As for the chamfering operation, it is also part of the group of 2D machining operations. We can perform chamfering using a contour machining operation, or we can do it using a dedicated strategy for chamfer machining. Let's choose this strategy, and now we will select the tool with which we will perform this chamfer. I click the select button, and here we will use the Fusion tool library. Select milling tools, and as for the chamfering tools, at this moment I want it to be a tapered end mill. These can be tools from the engrave group or from the countersink group. Let's choose, for example, this tool with a diameter of 10 millimeters and an angle of 90 degrees. I click select. Now we move to the geometry tab, and we will select this geometry as the geometry to be machined. I click OK to calculate this operation with the default parameters. Now we move on to simulate this operation to see how it will look. I start this simulation, and this tool works in such a way that it gently touches the machined contour, but does not perform this chamfer here. We need to adjust some parameter so that the chamfer is performed. Therefore, I close the simulation, go to edit this operation, and now I go to the passes tab. We have the chamfer width parameter, and let's enter, for example, 1 millimeter here. I click OK. Now the toolpath has been slightly lowered. We go to simulation to see how it will look. I run the simulation, and we already have the undercut on the material, and we have the chamfer completed. And this is how we will leave it. I close the simulation. If you want, you can also adjust the tool entry and exit here, but I will leave it as it is. And now we will proceed to perform the chamfer in the holes. We could also use this chamfering strategy here, but let's do it in such a way that we will use drilling strategy for this. We will simply add drilling to a specified depth to gently deburr the hole edge. I choose the drilling operation here. I leave this tool as the tool for machining and specify the hole geometry. Preparing the operation this way, it will simply be necessary to specify the drilling depth. Let's calculate this with the default parameters. I click OK, and it looks wrong. The drilling is simply performed too deep. Let's go back to editing this operation. We go to the Heights tab. Here, we will immediately change the bottom drilling level to hole top. And we will control the offset parameter value. Let's give an offset of -2 millimeters. I click OK, and let's see in the simulation how it will look. Will these edges of the holes be deburred at all? OK, we have the drilling prepared too shallow. I exit the simulation, edit the operation, go to the Levels tab, and I will set the drilling level to -6 millimeters. I click OK and run the machining simulation. Now it's definitely too deep. I exit the simulation. And let's change the value of this parameter to -3 millimeters. I am doing this intentionally to show you that in this way you can prepare machining, and that we do not have to specify all parameters immediately during the first attempt to add a machining operation, and those parameters don't have to be perfect right away. The CAM systems give us the possibility to introduce a parameter and to see the effect of that parameter on the toolpath and on the machining. So here I am playing with that a little deliberately to show you that you can also prepare machining this way, and that we don't really have to know everything when preparing machining programs. We can simply use trial and error to reach a point where the machining we prepared will be satisfactory, correct, and can be performed on a CNC machine. Okay, I am closing the simulation here, and we will end the machining of this part here. Thank you for watching, and please subscribe to this channel.